In this math counts preparation lesson, we are going to be checking out some number theory problem solving strategies. So let's get started. We have a group of 10 friends who are discussing a large positive integer. So the first friend says it can be divided by 1, it can be divided by 2, it can be divided by 3, it can be divided by 4, 5, 6, 7, 8, 9, 10. So each friend made such a comment. Two of the friends are incorrect, and those two friends said consecutive numbers. What was the least possible integer they're discussing? So basically, if friend 4 and 5 are wrong, they could be wrong. Two friends are wrong, and they're consecutive numbers. So that's what it means. What was the least possible integer they were discussing? First, we need to figure out which friends were wrong. And this is pretty easy. Let's just figure out all numbers are divisible by 1, so it can't be 1 and 2. We go to 2 and 3. Well, if it's not divisible by 2 and 3, it's not divisible by 6, so that's no, it can't be that. 2 and 3, 3 and 4, well, 3 and 4, that means 9 is not correct, and that means 8 isn't correct, so it can't be 3 and 4. And it can't be 5, or 4 and 5, it can't be 4 and 5. It can't be 5 or 6 either, since it's 5 or 6. If a number is divisible by 5, then it has to end in 0 or 5. That means a 10's wrong, so we can't have 5, 6. So really, we don't have to keep doing this. We only want to focus on the primes. You want to focus on 2, 3, 5, 7. These are the only numbers we want to focus on. We know 2 is a big no. 3, well, 9 has to be incorrect then. 5 is a big no. 7 we haven't tested. Let's test 6 and 7. Well, we know 6 is not out of the picture. Let's test 7 and 8. 7 and 8. Well, 7 and 8, if we're looking at 7 and 8, well, let's see, 7 and 8. So 7 and 8 actually work because if 7 and 8 are incorrect, it doesn't affect any of the other numbers. So really, we're good. Really, we're honestly good, because if a number is divisible by 8, well, there's no like big rule for that. So, and we don't even need divisibility rules to figure out that it's 7 and 8, both of which have no well-known divisibility rules. So we know friend 7 and friend 8 are both incorrect. So the incorrect people are 7 and 8. Seven and 8 are incorrect. So now we know our number has to be divisible by 1, 2, 3, 4, 5, 6, 9, and 10. Let's check our divisibility rules in constructive number. We're using some constructive number theory. And they're discussing a large positive integer. Notice that this large positive integer part doesn't really matter. Like, I could consider 10 to be a large positive integer. It doesn't really matter that way. So we'll try to construct any number. Like, we're going to build a case, and then we want to work our way down to get to the least possible integer that they were discussing. So use some constructive number theory, right? 10, we have 10 and 5. That means the units digit has to be 0. Well, it has to be divisible by 4. So if it's divisible by 4, we have a couple options. We can have 0, 0, we can have 0, 4, and we can have 0, 8. Since we want the least possible integer, I'm going to start with 0, 0 just to build a case. So we are going to have 0, 0. Satisfies everything so far. Well, not everything. Satisfies 2, 1, 2, 3, not yet, 4, 5, 6, not yet, 9, not yet, 10, yes. And we need to focus on 3, 6, and 9. We need to get the 3 divisibility down. Now, let's see what we can have over here. We can directly do this for 3, but we also need to do it for 9. So the divisibility rule for 9 is the sum of the digits is divisible by 9. So we can just place a 9 here. And the divisibility rule for 3 is if the sum of the digits is divisible by 3. 9 is divisible by 3. 2 and 3 are divisible by this number, so 6 has to be. And we've built 900 as a possible case, right? We want the least possible number they were discussing, however. Now we could just go ahead and work our way down. We're going to use some strategic guessing. We've used the constructive numbers theory strategy to build a case, and now we're going to work our way down until we get the answer. So we know we can have a 0. We have to have a 0 in the units digit. The 9, the hundreds digit needs to go down each time, since we want the least possible integer they were discussing. Notice we can also change this digit each time. We can make it a 4, 8, or 0. So we're going to do that. We're going to use some strategic guess and check to work our way down. Let's try this. Let's try 940. 9 plus 4 is 13, no. 980. 9 plus 8 is 17, no. We're going to move on to 8. I'm going to work from the biggest case. 880. 8 plus 8 is 16. Let's check out 16. Nope. Let's check out 840. 12. 9, no. Let's go to 800, which is not a case. 780. 780. 7 plus 8 is 15. Not 9. 740. Nope. 11 is the sum of the digits. We can have 700. Nope. Sum of the digits is 7. We can have 680. Nope. 640. Nope. 600. Nope. 580. Nope. 540. Yes, 540 is a possible case. 5 plus 4 is 9. Sum of the digits divisible by 3 and by 9. So we've come to a possible case. And we notice that if these two digits are divisible by, the sum of these two digits are divisible by 9, or they sum to 9, we're going to get the least possible integer. Now, how are we going to obtain the least possible integer? Well, we're going to want the hundreds digit to start with a 1. This has to end with a 0. Now, how can we build this so that it's divisible by 9 and by 3? Well, how can we build this? Well, 1 plus 8 is 9, so we can put in a 180. And 180, we see that 180 is the least possible integer they were discussing. It's divisible by all of these numbers. And we know that friends 7 and 8 were incorrect. We already solved the first part of the problem. So the least possible integer the 10 friends were discussing is 180. And if you go any down, you can see that the sum of the first two digits must sum to 9, in other words. That's how we're going to obtain the least possible integer. And we notice this large positive integer thing didn't really do much. You know, if we assume that our large positive integer 180 is not that large, well, that's a confusing factor, but we don't need, this doesn't matter. We can literally just cross this out. This does not matter. Alright, this does not matter at all. We can just replace this with an integer. Or a natural number, which is the same thing. So that is how we didn't even need to use guess and check. We did guess and check to figure out a trick that we can use to get here. So hopefully this video is helpful. And yeah.